Hi, my name is Sue. In this section, we'll look at some common strategies for problem solving. This includes making a table or a chart, looking for a pattern, solving a similar, simpler problem, drawing a sketch, using inductive reasoning, writing an equation and solving it, or if a formula applies, use it. We could work backwards, guess and check. We could use trial and error, or common sense and look for a catch if an answer seems too obvious or impossible. In this first example, we're asked in how many ways can we make $1 out of using a combination of nickels, dimes, and/or quarters. Without actually taking out the coins, making a chart of all combinations would be very helpful for solving this problem. We also need to read the problem carefully and see that we can only use a few types of coins in our combinations. So let's start by making a chart with quarters, dimes, and nickels at the top. So I've added a chart to the screen here, and I added 3 sets of it because it's going to have more than just a handful of combinations. So I need to make sure I have plenty of room. And it doesn't matter what order we work out all the combinations in, as long as we stick to a pattern. So it'll be easier to see if we have all the combinations or not. So I'm going to start with 4 quarters. So 4 quarters already makes $1. So that would be no dimes and no nickels. And then I'm going to work my way down with quarters. So for example, if I have 3 quarters, that's 75 cents. So I could have 2 dimes, which leaves me with 1 more nickel. And I'm going to continue with 3 quarters until I'm out of combinations. So I'll count down my dimes now. So if I have 1 dime, then I would need 3 nickels. And there's 1 more combination here. So if I have 3 quarters and no dimes, then that would leave me with 5 nickels. So those are all the combinations of having 3 quarters. So if I move on to only having 2 quarters, which is 50 cents, well, I could have 5 dimes and no nickels, or 2 quarters with 4 dimes, then would add 2 nickels. And 2 quarters with only 3 dimes would add 4 nickels. You can see a pattern forming here. Every time we trade a dime, we have to add 2 more nickels. So we could have 2 quarters with 2 dimes, which would be 6 nickels. And then 2 quarters with 1 dime, which would be 8 nickels. And then 2 quarters with no dimes, which would be 10 nickels. So that's all the combinations of 4 quarters, 3 quarters, and 2 quarters. So I'm going to move over here for 1 quarter. And if I have 1 quarter, now we have a lot of money left. So I'll start with the most. Since this is 25 cents, I could have as many as 7 dimes with 1 nickel left over. Or I could go down to 6 dimes with 3 nickels. Or I could go down to 5 dimes with 5 nickels. Again, every time we go down a dime, we go up 2 nickels. So 1 quarter with 4 dimes would be 7 nickels. 1 quarter with 3 dimes would be 9 nickels. 1 quarter with 2 dimes would be 11 nickels. 1 quarter with 1 dime would be 13 nickels, and 1 quarter with no dimes would be 15 nickels. The last set we have to do is, what if we don't have any quarters? Well, the most we can have for dimes to give myself $1 would be 10 dimes, and that would leave me with no nickels. Or I could have 9 dimes, which would then trade to 2 nickels. Or I could have 8 dimes with 4 nickels. I could have 7 dimes with 6 nickels. I could have 6 dimes with 8 nickels. Again, I'm counting down the dimes, and every time I remove a dime, it changes to 2 nickels. So now we have 10 nickels. Or I could have 4 dimes with 12 nickels, 3 dimes with 14 nickels, 2 dimes with 16 nickels, 1 dime with 18 nickels, and no dimes, no quarters, but 20 nickels. So these are all the combinations that we can have. I just need to count 1 column of things. So if I just look down the row of, say, dimes, there's one combination with 4. There's 1, 2, 3 combinations here. And then there's 1, 2, 3, 4, 5, 6 combinations with 2 quarters. And there's 1, 2, 3, 4, 5, 6, 7, 8 combinations here. And then in this last column, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 combinations. So these are all the different combinations we have. So if we add that up, that gives us 29 different ways to make $1 out of only nickels, dimes, and quarters. Example 2. Mary read 58 pages of her book. If she still has 3/4 of the book left to read, how many pages are in the book? Well, we could approach this problem using several of the methods mentioned at the beginning of the video, but I would like to show how drawing a sketch can often make a problem simpler than it appears. So we know that she has read a certain number of pages, 58, which is not the same as the part of the book which is left, 3/4. So I'm going to draw a picture of a rectangle or a book and cut it up into 4 equal parts. So here's my book. And I'm going to go ahead and cut my book into 4 equal parts. Now, we know she read 58 pages. So this is how much she's read. And she still has 3/4 of this book to read. Well, if 3/4 are left and she has read 1/4, which must be 58, then these also must be 58. So it says, how many pages are in the book? Well, I can see that each quarter is 58. So I would take 58 and I would multiply it by 4 sets of a quarter. And that would give me 232. So this entire book must have 232 pages. All right, example 3. The sum of 8 consecutive whole numbers is 132. Find the sum of the first and the last numbers. Well, since we have so many numbers and they are in consecutive order, this is a good example for creating an equation to solve the problem. So let's start by defining our unknowns, which in this case are the 8 consecutive whole numbers. We cannot assume the first number is 1, so we have to use a variable for it, say n. So I'll call the first number n. After that, each consecutive whole number is 1 away from the previous number. So we can keep adding 1 to each unknown to get the next unknown in our sequence. So our second number will be n plus 1. Our third number will be n plus 2. Our fourth number will be n plus 3. Our fifth number will be n plus 4. Our sixth number will be n plus 5. Our seventh number will be n plus 6. And our eighth number will be n plus 7. So we have all of our unknowns. As we reread the problem, it states that the sum of these 8 numbers is 132. So we need to add up all of the unknowns, giving us, if you look, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 n's. And if we add up all the whole parts, I could add a 0 here if that helps, but if we add all these integers together, all these whole numbers, we get 28. This is our sum. And they told us that the sum is 132. So we're able to come up with the equation 8n plus 28 is 132. So now I have an algebraic equation to solve. So to solve this equation, I'm going to start by subtracting 28 from both sides. This will leave me with 8n is 104. Then the next step is divide both sides by 8, leaving us with n is 13. So if we look back, n is our first number. You have to look carefully at the question. It says find the sum of the first and the last numbers. So if this is the first number, now we need the last number. The last number is n plus 7. So n plus 7 then is 20. This will be my last number. So together, 20 and 13 then would give me a sum of 33. In this lesson, we looked at a few problem-solving approaches. Now it's time to go into the homework section and work some problems on your own.